Hello students of class 10, this is your general maths exercise 1.1. Uh, in this video we will do a revision. So this is your first question. Use Euclid's division algorithm to find the HCF of. Okay, so in here you see exercise 1.1. Use Euclid's division algorithm to find the HCF of 135 and 225. So from each type I will do only one sum. Okay, since it is a revision, therefore from each type I will do one sum. So this one you see, since 225 is greater than 135, okay, since 225 it is greater than 135, so therefore by Euclid's division algorithm we have, so this is your type 2. So that any positive odd integer, is of the form, 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Okay, where q is some integer. So that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. So in here I will take that, first of all I will write, let A be any positive, integer, and b is equals to 6, I will take. Okay, then by Euclid's algorithm, A is equals to 6q plus r, for some integer q greater than is equals to 0. Okay, and r will be 0, 1, 2, 3, 4, 5. Okay, r value will be 0, comma, because r is greater than is equals to 0 and less than 6. Okay, first of all you will have to write this one. Okay, so therefore you see a value, okay, therefore a value, it can be 6q when r value is 0. Okay, in 6q plus r, when r value is 0, a value it can be 6q Okay, a value it can be 6q, or it can be 6q plus 1. Okay, or it can be 6q plus 2, or 6q plus 3, or 6q plus 4, or it can be 6q plus 5. Okay, a value can be 6q, or 6q plus 1, or 6q plus 2, or 6q plus 3, or 6q plus 4, or 6q plus 5. Okay, now uh, now I will say that uh, okay, now if, okay, uh, if a is equals to, now if a is equals to, I will say if a is equals to 6q, okay, a is equals to 6q, or 6q plus 2, or 6q plus 4, okay, then a is an even integer. Okay, then a is an even integer. If a is 6q, or 6q plus 2, or 6q plus 4, then a is an even integer. Okay, uh, so this one full stop I will give. Next I will write that a positive integer can be either even, a positive integer can be either even or odd. A positive integer can be either even or odd. Uh, therefore, I can say that any positive, therefore any positive odd integer, is of the form 6q plus 1, or 6q plus 3, or 6q plus 5. This one you can. So first of all, in here you see question saying so that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. So you can take that let a be any positive integer and b is equals to 6. Then by Euclid's algorithm, a is equals to 6q plus r you will get for some integer q greater than is equals to 0. And r value it will be 0, 1, 2, 3, 4, 5. Okay, because you see r is greater than is equals to 0 and less than 6. So therefore a is equals to a value it can be 6q, or 6q plus 1, or 6q plus 3, or 6q plus 2, or 6q plus 3, or 6q plus 4, or 6q plus 5. Okay, now if a is 6q, or 6q plus 2, or 6q plus 4, then a is an even integer. Understand, a is an even integer. So next, a positive integer can be either even or odd. Yes, a positive integer can be either even or odd. Therefore, any positive odd integer is of the form 6q plus 1, or 6q plus 3, or 6q plus 5. So next, this is your number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, so in here first of all I will take, let a be, okay, let a be let a be any positive integer, and b is equals to, b value I will take 3. Okay, a be any positive integer and b is equals to 3. Then by Euclid's algorithm, a is equals to 3q plus r. Okay, a is equals to 3q plus r for some integer q greater than is equals to 0. Okay, and r value, it will be and r is equals to 0, 1, 2. Okay, r it will be 0, 1, 2 because r is greater than is equals to 0 and less than 3. Okay, r is greater than is equals to 0 and less than 3. Okay, so therefore a can be 3q. Okay, when r value it is 0, then a will be 3q, or it can be 3q plus 1, or it can be 3q plus 2. Okay, so this is your first case, number I. A it is equals to 3q. Okay, a it is equals to 3q. I have to show that question, you see, I have to show that the square of any positive integer. Okay, a is a positive integer, and the square of a positive integer is either of the form 3m or 3m plus 1. Okay, so therefore this one I will have to square it. Okay, 3q the whole square. So this one is equals to, I will get 9q square. Okay, now 9q square I can write it as 3 bracket 3q square is equals to 3m. Okay, where m it is equals to 3q square. Okay, m it is equals to 3q square belongs to z. Okay, okay, m value it is 3q square belongs to z. Finished. Next again number 2 I will take. Now this time I will take a is equals to 3q plus 1 I will take. Okay, this time I will take a is equals to 3q plus 1 I will take. Again what I will do, squaring both sides. A square is equals to 3q plus 1 the whole square. So this is, I will get 3q the whole square plus 1 square plus 2 into 3q into 1. This is, I will get 9q square plus 1 plus 6q I will get. Okay, so now let me write this properly. Okay, this one let me write this thing properly. Therefore a is equals to 3q or 3q plus 1 or 3q plus 2. Okay, this is your first. A is equals to 3q, then squaring both sides I will get a square is equals to 9q square. So a square is equals to 3 into 3q square I can write. So a square is equals to 3m, where m it is equals to 3q square. 3q square belongs to z. Okay, belongs to z. And in the bracket I will write, since q belongs to z. Okay, since q belongs to z. Next I will take a is equals to, when a it is 3q plus 1. Now squaring both sides I will do the whole square. So this is 3q the whole square plus 1 square plus 2 into 3q into 1. This is 9q square plus 1 plus 6q I will get. So this one you see I can write it as 9q square plus 6q plus 1. From here I can take 3q common. Okay, 3q common I will take. Then this one it will become 3q plus 2. Okay, plus 1. So this one I can write it as 3m plus 1, where m is equals to m value, it is q bracket start 3q plus 2, and this things belongs to z since q belongs to z. Okay, since q belongs to z. And the last you see the third one, the last you see number third, when a is equals to 3q plus 2. Okay, again squaring both sides, 3q plus 2 the whole square is equals to 3q the whole square plus 2 square plus 2 into 3q into 2. So this is equals to 9q square plus 4 plus 2 to the 4, 4 3 is 12q. So this one I can write it as 9q square plus 12q plus 4 I can write it as 3 plus 1. From here I will take 3 common. Okay, from here I will take 3 common. So I will get 3q square plus 4q plus 1 I will get. Understand? So this one whole thing I can write it as, 3m plus 1. Okay, 3m plus 1, where m is equals to q, 3q plus 2 belongs to z since q belongs to z. So this one where m value it is how much? It is 3q square plus 4q plus 1 belongs to z. Okay, belongs to z bracket since q belongs to z. Understand? So therefore I can say that after that the last line. Okay, last line you see question, it is saying type 4 you see question it is saying that the square of any positive integer, okay, the square of any positive integer can be expressed in the form of 3m or 3m plus 1. Okay, question it is saying that the square of any positive integer can be expressed in the form of 3m or 3m plus 1. Understand? So therefore let a be any positive integer and b is equals to 3. Then by Euclid's algorithm a is equals to 3q plus 1 for some integer q greater than is equals to 0 and r is equals to 0. R value it can be 0, 1, 2. Okay, because r is greater than is equals to 0 and less than 3. So therefore a it will be either 3q or 3q plus 1 or 3q plus 2. So when a is equals to 3q, then squaring both sides I will do. Okay, a is a positive integer. It is a positive integer. I have to show that the square of a positive integer is either of the form 3m plus 1 or 3m plus 2. Understand? That is asking. It is asking the question. Okay, so therefore when a value it is 3q, then squaring both sides I will do. So a square I can write it as 3 into 3q square. So a square it will become is equals to 3m, where m value it is 3q square. It belongs to z. That means m is an integer. Understand? Or you can say that 3q square is an integer. Why 3q square is an integer? Because q is an integer. We have already said for some integer q greater than is equals to 0. Next I will take when a value it will be 3q plus 1. Again squaring both sides I will do. And again this one you see I can write it as 3m plus 1. You understand? The square of a positive integer can be written in the form of 3m plus 1. This one again 3m plus 1. Understand? So therefore the last line I can write, therefore the square of a positive integer, okay, therefore the square of a positive integer is, okay, the square of a positive integer is of the form 3m or 3m plus 1. Understand? The square of a positive integer is of the form 3m or 3m plus 1. Okay, same thing only, or you see how it was done in the class. Okay, how it was done in the class. So this one, your question number 5, 6 and 7 you try to do by yourself. Everything it is done in the class. Okay, everything it is already done in the class. So your general maths, your syllabus for the first unit test, okay, your first unit test, it will come up till you see it will come up till here, okay, it will come up till page number 88. Okay, this is your general math syllabus for first unit test. Okay, it will come up till page number 88, and this one, the first chapter, which is your revision, the syllabus it is already given, the first chapter it is revision, so this chapter also it will come. I hope you understand the first chapter, that is your revision. Okay, this chapter it will also come, this one, these three chapters, that means your first chapter it is revision, real numbers, polynomials and pair of linear equation in two variables, that is up to page number 88. Okay, chapter 3 up to page number 88, understand? So your first, this is revision, from revision also it will come, understand? So these things I hope you can do, okay, because it is a revision. Most of the things you have already learned in your lower classes. I hope you have understood. Thank you.